Hello everyone. In this video we will discuss about the structural isomers. So before I explain what is structural isomers, let me show you a couple of things and then you can decide what is a structural isomers is. So let's draw a straight carbon chains with 4 carbon atom. So we got that. So we have hydrogen on either side. So remember, you don't have to connect straight. You can connect anywhere. It's like a Legos, right? So all you have to be worried about is each of the carbon should have 4 bonds around it. That's it. So what is the name of this one? We got 4 carbon atom. 1, 2, 3, 4 carbon atom. So what is the name? It's gonna be 4 is bute, and these are all single bonds, so it's gonna be butane. All right. What is the formula for this one? The formula is gonna be C4. uh, how many hydrogens? You don't have to calculate, you don't have to count, you can do it by yourself. So it should be 4 multiplied by 2 plus 2. So that is how much? 4 to 8 plus 2, 10. 10. Remember the rule, Cn H2n plus 2. That's how I got here. All right. Or you can just calculate each one of these. So it's 3 to 5 to 7, 3 tenths. All right. So this is one structure of butane. Can I draw another one? Instead of connecting the 4th carbon atom at the end, I'm gonna connect here. Remember, these are carbon, they can be connected and stacked any way you want. So all you have to be careful about is each one of them should have 4 bonds around it. So now every carbon has 4 bonds. So let's fill out all the empty spots with hydrogens. H, 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 H. So if this is the expanded structure, so if I draw the condensed structure, how this one should look like? This one should look like CH3. The center one has only 1 hydrogens. Then there is something pointing downwards. That one has CH3. And there is something on here. All right, so that's our condensed structure. So let's look at the formula. What is the formula for this one? Then we'll get back to the name. So the formula for this one is C. How many carbon atom? We got 1, 2, 3, and 4 carbon atom. How many hydrogens? We got 3, 3, 6, 3, 9 plus 1, 10. Now look at this. Both of them has 4 carbon atom, 10 hydrogen atom. But can we call both of them as butane? No, because this molecule is completely different than this molecule on the left. So although they have the similar formula, they are not the same. So these are two different compounds. So what are the isomers? So isomers are the compounds which has same molecular formula, which is C4H10. You can draw multiple of those for different compounds, but the compounds with same molecular formula but different structure. So that's what the structural isomers are. Compounds with same molecular formula but different structure. All right, so that's the definition of structural isomers. So if we cannot call it butane, what shall we call it, right? So we're gonna give a name. So now we're gonna learn some complex nomenclatures. All right, so I'm gonna rewrite the rule here. So this is CH3, CH, CH3. Okay, rule number 1, if you have a, so these are called branched, because this is branching out. So these are called branched chain alkane. These are still alkane, by the way. This is just branched. So the first rule, find the longest straight chain. Okay, find the longest straight chain. So in this case, what is the longest straight chains? This is the longest straight chains, right? 1, 2, 3. So whichever is the connected one after another time. I should not call straight, maybe I should call it find the longest linear chain. It doesn't have to be always like this. I could have gone like this. This is also called as a straight chain, so it's going one after another. So find the longest continuous chain. I think I should call it continuous chain. That would be way more appropriate. Continuous chain. Okay, so once you find out, count how many carbon atom it has. It has 1, 2, 3. So it doesn't matter for this molecule, you go either directions, you always gonna get 3. So you have find the longest continuous chain and count the atom, count the carbon atom. All right, so how many carbon atom we got? 3. 3 equals to propane. So the propane is going to be the parent name for this one. All right, so now we're gonna work on prefixes. So if this is the longest chain, this one is gonna act as a substituent. Substituent. All right, so what is the substituent? So count the substituent carbon atom. Okay, how many substituent carbon atom we have here? Substituent has only one carbon atom. So if it has one carbon atom, the one is meth, and substituent usually ends with YL. So this stands for substituent. So one carbon atom because meth, and it's gonna be methyl. So that's gonna be our count the substituent carbon atom. So our answer is one carbon atom. So one carbon atom is meth. Because it is a substituent, we're gonna call it methyl and use that as a prefix. Prefix. So the name so far, what we got methyl propane. It's a one word, by the way. So this is the prefix, this is the parent name, this is the actual name. Okay, so last thing you want to do is assign positions for substituent. Okay, so what is the when you assign positions, pick the list number. So what do I mean by position and list number? So let's look at this one. This methyl group is attached to the second carbon atom of this parent chain. 1, 2, 3. This methyl group is connected to the second carbon atom, right? So it's gonna call the position is second carbon atom. So we're gonna call it 2-methyl propane. That's it. That's the final answers for this one. 2-methyl propane. Okay, so for this particular compound, I don't have to go this directions. I could have gone linear and still I would have got the same answer. So let's say this is my parent chain 1, 2, 3, which is also a propane. And where is the substituent? Substituent is this one. So that seems fine. And then where is the substituent is connected? Substituent is connected to the second carbon atom. So it's still gonna be 2-methyl propane. Okay, let's do a bit more complex right now. We will follow the same pattern. Okay, I'm gonna erase all the things here so that we can do something. So we will follow the almost the same principle. Okay, so let's say something like this. Yeah, I think this looks fine. Okay, so what is the name of this compound would be? So first thing that you want to do is find the longest chain, longest continuous chain. So one way, so this is the longest continuous chain, right? 1, 2, 3, 4, 5, 6. So it has 6 carbon atom. Some people, this is a common mistake people do initially. They say this is the linear chain, but this has only 4 carbon atom, but you still have to add 2 more, right? So this is 4, this is 5 carbon atom continuous, but you gotta find the best possible combinations, right? You cannot use this either, you cannot use this either. So the best and longest is this, which is connected one after another, right? Okay, so how many carbon atoms? 6. 6 carbon atom. What is the parent name? Is gonna be hexane, so that's the parent name. Okay, what is the substituent? Substituent is methyl. All right, substituent is methyl. So count the substituent, so which is 1 carbon atom, so that is methyl. So our name would be methyl hexane. So methyl hexane, but we gotta assign where the location of methyl. Okay, now this is where you have to be very careful. So how would you number the carbon atom? Well, if I number like this is the first, second, third, fourth, fifth, sixth. Okay, so in this case, the methyl group is at the position 3. But what's stopping me from numbering from right to left? I can number this as my first, second, third, this is fourth, fifth, sixth. So you have 2 alternate universe. I can number from left to right. You can number from right to left either. So you are getting 3 methyl or 4 methyl. So if you are getting conflicting numbering system like this, always pick the lowest. So the answer would be 3 methyl hexane. That's the answers, 3 methyl hexanes. Okay, let's do one last. I'm gonna give you a bit more complex one. Let's just ignore the hydrogen for now. Okay, so this is it. What shall we name? Let's just don't worry about the hydrogen. This is the carbon chain. All right, so find the longest linear chain. Which one would that be if I find the longest? So this is my longest, right? So how many carbon atom we got? 1, 2, 3, 4, 5, 6, 7. So this is 7 carbon atoms. So parent name is gonna be heptane. That's good. So what are the substituent? This is a substituent, this is a substituent. Okay, so now you have two substituents, right? So the way we write two substituents is, let's look at each one of them. This one has one carbon atom. This is also one carbon atom. So it's kind of pretty easy to write down meth. So it's a substituent, it's gonna be methyl, methyl. Because they are the same substituent, we can write them as instead of writing methyl methyl, we write them as dimethyl. Di is 2. So far our name becomes dimethyl heptane. It's a one word, dimethyl heptane. Last thing you want to do is you want to number them. You want to mention what is the location of these. So you can number from left to right. 1 2 3 4 5 6 7. Taste from either direction. So I can number 1 2 3 4 5 6 7. Okay, so let's do left to right. So if I do left to right, what is my name would be? It's gonna be substituent at the carbon atom 3. Maybe I should delete the left to right for here. Let's do one at a time. Okay, so the first substituent at the carbon atom 3. The next substituent is at carbon atom 5. So it's gonna be called as 3,5 dimethyl heptane. So that's one way to number. You should always check on either side because I'll explain in a second. If I number like this, what is my name would be? It's still at the location 3 and location 5. 3,5 dimethyl heptane. If you have a conflicting number, like if you are getting two different numbers from two sides, pick the lowest. Like don't add them up. Whichever has the lowest number is gonna be the winner. So maybe we can have another example. So in this case we got lucky, so it's gonna be the same. So let's do another example here where you have to be different. So I'm gonna use the exact same. Okay. Okay, find the longest chain. In this case, this is our longest chain. How many atoms we got? 1 2 3 4 5 6. So that is hexane. What are the substituents? We got two substituents. Methyl, so it is a dimethyl hexane. Let's find the number. Okay, if I number from 1 2 3 4 5 6, if this is my numbering system, what are the substituents? Substituents are carbon atom 3, carbon atom 5, so that's our 3 5 hyphen dimethyl hexane. So this is one way to number. The other one would be from right to left. So I'm gonna start here. 1 2 3 4 5 6. So this one would give me the methyl at 2 and 4. So this one would be 2 and 4 dimethyl hexane. So the correct way to do it is this one because 2 is the smallest. So your goal is to give the smallest number. So this one would be wrong. So you pick the lowest number, not the additions or just pick whichever has the lowest number. So that's the number. All right, this is where I will stop.